We are going to start by welcoming Mila, who is the Director of the Pan-Canadian AI Strategy at CIFAR, who is one of our sponsors here today. She leads the global delivery of the Canada CIFAR AI Chairs Program, Next Gen AI Training Programs, and the AI and Society Program. So please join me in welcoming Mila Chowdhury to the stage. All right, enjoy.
Hi, everyone. It's an honor to join you today at today's meeting, a gathering of women driving the future of AI. I'd like to just quickly introduce the CIFAR Pan-Canadian AI Strategy. It was launched in 2017. It was the world's first national AI strategy. What was its goal? To position Canada as a global leader in AI while ensuring that technology is developed ethically, inclusively, and for both social and economic benefit. The strategy supports top AI research, builds diverse talent pipelines, and fosters international leadership. We also partner closely with Amy, Mila, and the Vector Institute. We have many of their representatives in the audience today, so please make sure you're getting an opportunity to meet with them. And crucially, the strategy emphasizes equity and inclusion. As we shape the future of AI, our voices matter. Let's make sure that they're not only heard, but we're leading too. Okay, and now on to our exciting panel today. AI agents are redefining what's possible beyond prediction, enabling autonomous, goal-driven systems that are capable of acting within complex environments. This panel will explore where AI agents stand today, when they should be used and when they shouldn't, and how organizations can embrace them responsibly. So I'm pleased to introduce our moderator and our panelists for today. First, I'll start with our moderator. We have Karla Congson, a pioneering technology leader and serial entrepreneur at the front of AI innovation. As CEO and CTO of agentiiv, she architects proprietary AI agent platforms that transform how organizations harness AI for enhanced productivity and risk management. Next, we have Joelle Pineau. Oh, yes, clap. Let's clap for Karla. And then next, we have Joelle Pineau, who was the VP AI Research at Meta, leading its fundamental AI research team with labs across Canada, US, and Europe. She's also a core member at Mila and a professor at the School of Computer Science at McGill and a Canada CIFAR AI chair. Give a shout out to Joelle. Next, we have Anand Nimkar, who leads Deloitte Canada's applied AI practice. He has extensive experience delivering strategy and implementation programs of AI platforms at leading banks, insurers, airlines, retailers, telecoms, and public sector entities. Some of Anand's recent client success stories in generative AI have won Tech AI Awards and have been profiled in the Wall Street Journal, Financial Times, on Google Cloud Blog, and will soon be featured in Harvard Business Review. Let's give a clap to Anand. And last but definitely not least, we have Cari, who is an accomplished cultural and digital transformation leader. As the former head of AI and emerging technology at Canadian Tire Corporation, she led the development and implementation of a data and AI strategy, enablement and adoption for automation and AI resulting in revenue growth, increased employee and customer engagement, and productivity gains. Please join me in welcoming all of our panelists and really looking forward to this panel discussion.
I think we could. Where would you like us to?
Right. I am excited to launch this afternoon's panel, especially after the incredible discussion that we had earlier today around scaling AI and enterprise. So now we're going to zoom in on the state of agentic AI. And it's without a doubt that we're seeing incredible velocity on the launch of agent-based systems, and it seems like decades are happening in days. It ranges from research labs to industry POCs. And the best joke that I've heard actually very recently from the head of innovation at one of our banks was that they had more pilots than Air Canada did. But there's, and that sort of indicates that there's still a bit of a gap between experimentation and scalable agentic AI. And so I'd like to start with a bit of a state of the nation. So Anand, give me your definition of what agents or agentic AI is. And then looking at the clients that you work with, describe the state of evolution of AI agents in terms of real world maturity, actual production level cases.
Yeah, so AI agents they're essentially programs that are backed by LLMs that have some autonomy in the tasks that they're taking. They have some reasoning capability around a kind of narrow domain, typically. And then they have access to tools and data, like content. And so the way they interact, they interact with humans directly, they could interact with other AI agents, but it's essentially a decomposition of a process or a workflow that's enabled and facilitated by autonomy of these AI systems. That's kind of how I define it. And then your question is about kind of scalability. So what I'm seeing in market is, we are several model generations in. On the commercial side, we're seeing a lot more in the open source space from Meta and others. The reliability of these systems has increased quite a bit. So a common rift between like POC to production is just getting reliable, repeatable outputs for a vast quantity of inputs, even things that you're not expecting. And so there's been a lot of investment at the tooling level to enable reliability with tuning as well, with techniques like reinforcement fine-tuning, the use of synthetic data, and then a lot more investment in distributed systems to actually enable these things to scale up in a low latency, high throughput way. So I think now we're starting to see a lot more POCs move to production as a result. And there's a lot more rigor around testing and evaluation that's enabling that to happen.
No, that's excellent. And that's a great point that you made around reliability as really being that chasm, right, for scalability. Joelle, I mean, you've got a great perspective from both Mila and Meta, looking at a number of enterprises. Talk to me about the gaps that you see between hype and reality when you look at the adoption of agentic AI.
Mm-hmm. I think if I can add maybe some nuance to the definition, which by and large I completely agree in, but to put it sort of more in a historical perspective, I think we had many years of AI where the dominant paradigm from machine learning was the ability to do predictions, and predictions are pretty narrow, and so it's easier to get reliability from them. Now we're in the second age, which is the age of generative AI, and so the output of this is mostly like generating content, whether it's language, images, videos, sound, all the above. What's interesting about generative AI is it's a lot more nuanced to judge the quality of the output, and so in fact we've had to rely increasingly on humans to evaluate the quality and shape the behavior and so on and so forth. When we get to agentic AI, this is the era of AI systems that take actions. Really, if I distill down that definition, it's really all about taking actions. And so if you look at, to go back to your question, at the risk profile of a system that is going to make predictions, and someone else may or not act on these predictions, but someone's going to verify that information. A system that generates information, and then a system that takes action, you open up a whole new door in terms of wonderful use cases and potential, but also some difficult problems. To pick just one, but there are many others. In the age of generative AI, we've been worried about misinformation. We've been worried about hallucinations. If you transpose that to agents, the equivalent of that is impersonation. So you have AI systems that start taking actions on your behalf, which may or not match your goals, your desires, and so forth. So I think that's one. Another big one is, by their very nature, agents may be called to interact with each other. And so that adds a lot of complexity because you move from having essentially like a static system to a dynamic system. And we have a lot less ability to define the predictability of that system to make sure that it stays in points of stability. And in the microcosm where we've deployed agents, if you think, for example, trading bots, we've certainly seen some behavior where the interaction between the agents led to some difficult situations. Same with the vehicles. We've built autonomous car, and everyone spent ages, pulling their hair out about the trolley problem. When in fact, what happens if you get like a whole bunch of Waymos stuck in a parking lot, like beeping at each other, and someone can't sleep in the building next door? So, like, our ability to predict where these things are going to go wrong is actually quite difficult. And from these few sandboxes of agents we've seen, there's a lot of challenges.
No doubt. I need to look up the Waymo cars beeping at each other, actually. With all the discussion around agents, it's easy to forget that ML has been here for longer than a couple of years, right? And there's a lot to be said for problem-first AI, whereas often these POCs run to solutions as opposed to the problem first. So Cari, what's great is Canadian Tire has been a leader in AI adoption. Can you tell me a little bit more about problems, a great problem space where agents actually trump traditional ML?
Yeah, absolutely. And just to add on to what my esteemed panelists had talked about, the way I like to think about agents is really sensing, deciding, and acting, and the use of agents to really connect systems and to orchestrate that connection. And so when I think about a problem space, and I'll give you an example of a problem space in retail where some retailers are using agents to help solve for that problem, and I think everyone can relate to, is around low stocks on the shelf. So I'll just tell a little story here. It's going to be really, really hot this weekend, let's hope. And there is an agent that detects, based on real-time sales data, that the inventory of water bottles is lower than it needs to be. Okay, so that's the sensing. Then what that agent does, and you have an analytics agent, is that analytics agent will then look at different types of information. It will look at, has there been any marketing campaigns, for example, that are selling these water bottles at a promotional price? It will look at what are the past sales over a 7-day period, for example, of these types of water bottles during this type of heat. So it will start to take all of that context, and it will sense that, maybe there's something that needs to be done. Then what it will do is it will make a decision. So it will make a decision, which is the prediction of, okay, during this type of heat, when there's this type of marketing campaign, and we have this low of inventory, we need to make a decision that, we need to order more water bottles. So then there's the act, and the act is really around, okay, now what does the agent do? The agent might make the order. The agent might then notify the store manager, for example, and say, I've made this order. We need to ensure that there's staff that are, at the back ready to receive the order. The agent might say, we need to schedule more people because there's a heat wave coming, and we know that some of our categories are going to go way up. So those are the kind of things that act upon. And then ultimately, what ends up happening in that type of situation, the problem that gets solved for is you have a happier customer, you have a more efficient, streamlined process where you don't need 4 different people to do all of that work, and they're able to focus on the customers, for example. And finally, you have reduced the opportunity to lose your sale. And so as an organization, you're actually making more money. And in machine learning, or even generative AI, with the machine learning, you would have been able to predict that there is going to be a spike in demand, but you would have not acted on it. And with generative AI, you may have been able to summarize all of that information, but once again, you wouldn't have been able to act on it.
Oh, that's excellent. That's excellent. Now, in the speed at which we're experimenting, we're developing, it's incredible, the number of launches that seem to happen weekly, if not daily. Failures is as important as successes. So Anand, you've got a great perspective cross-industry. What are some failures that we can learn from that you've observed?
So I'll say, actually, to make things reliable, so that process you articulated, now, if it goes according to plan, it's amazing. The benefit's awesome, right? We essentially will have time savings, we'll have a happier customer, more efficiency. But making that reliable is a huge endeavor. And actually, when I think about failure, you can think about it at the micro level for each agent. Every potential action, everything they're reading, every inference or reasoning step that they take, we need to be able to measure and improve, right? And one mechanism of actually doing that is to induce failure. So through synthetic data, through red teaming, whether we do simulated red teaming with other LLMs doing it, and some optimization techniques on top, or we do it with people. The point of it is we need to make reliable systems, you need to induce all the potential failure modes for every given step of the process, and then use that either to tune the prompts or the instructions or the in-context examples, or tune the weights of the model when you're using an open model. So that's kind of my general statement on failure. I think with regard to overarching failures that I've seen in industry, I do see that there's definitely a lot of POCs, and they're not anchored to any clear benefit. So I think it's very important that when we look at a process to introduce agents into, that we understand end-to-end how they will be deployed, the change management implications of that, how they'll be adopted, and then what the financial benefits will be of that. And then correctly also articulate and project the costs. I know that my teams, when they actually architect these solutions, they actually think about every possible message and step in every possible condition. They create all the probability scenarios of that happening, and then they measure the number of tokens so they can do a calculation on cost. And on the flip side, the product teams are working with the business, trying to extract exactly where the benefit will come from, whether it's time savings, whether it's some type of efficiency metric or KPI, without having that rigor up front. And it's the same rigor for any technology project. Most of these projects would be doomed to fail, just because the level of investment needed to actually get them reliable is pretty significant.
Oh, that's excellent. That's excellent. Now, no discussion about agentic AI would be complete without a conversation about risk and regulation. And it's not surprising that explainability and interpretability have become very hot topics. So let's start with evaluations. They don't get nearly the same spotlight as automation and POCs, but they're becoming very important as the systems become more complex and as workflows and orchestrated multi-agent systems get more complex. And there's a ton of benchmarks, whether you believe in them or not, but there are a lot for models. Now, Joelle, when we take a look at best practices for agentic evaluations, what have you observed out there? Because that's less linear.
Yeah, it's actually, it is actually a quite difficult space. Something I've thought about quite a bit, because my research expertise is actually in reinforcement learning. And reinforcement learning has this characteristics of making decisions and taking actions. And one thing you learn very early on in reinforcement learning is that the only way to do the evaluation of the behavior, which we call the policy of the agent, is by running it. Like, you can't do evaluation on a held out test set, which you do for supervised learning. And so that makes things a lot more complicated, in that you need to deploy the agents. Now, there are some cases you may not want to deploy the agents in real world conditions because you're too early on in the development curve, or because there's actually safety risks to doing that. And so you need to create some sandboxes where you do this evaluations. But again, like, these sandboxes need to be interactive. So the agent has to interact with an environment that actually has representative dynamics and a good set of the wide variety of conditions. And so sometimes creating that environment is actually more work than creating the agent itself. I would say one of the ways that we've made the most progress in AI over the last few decades, in particular machine learning, is through the creation of data sets and benchmarks. So we always talk about like data and evaluations as being like really the things that anchor the work. And even through my many years of working at Meta, I was supporting the fundamental AI research team, but there was certainly an ambition to take a bunch of these things into product. And some of you who may have used some of the latest editing tools on Instagram, for example, that came directly out of a model called Segment Anything that we developed in the research teams. And so the interface between the research team and the product team often came down to that, like data and evaluations. Right? Like give us some of your data to make sure that we're capturing that when we train the model, and set the evaluations, and we'll make sure that the models perform up to performance. And so I think as a community, we have, going back to the question of agents, we have tremendous amount of work to do to develop the right benchmarks and sandboxes to do these evaluation. Some kind of sandbox for robotics are typically robot simulators. But there's other ways to do it. There's been a few good benchmarks developed recently. SWE-bench is one of them that folks are using. But I do think there's a lot of space to do more of that work. And if that work is done well, that in itself will really drive the progress.
It's a huge unlock, right? Because it comes back to reliability. So I want to build on what you've said, because you focused on the behavior of agents. And I think what's becoming clear to many enterprises is that AI and agentic adoption is as much a technology problem as it is a talent problem, or opportunity, as you would. And because Pandora's box is unleashed, right? And we can't control the technology and how people use it. So governance frameworks and architectures are equally important to just simple technology deployment. So let's take the people side of things. What governance frameworks and architectures are you seeing effectively deployed?
For agents specifically, I think we're in very, very early days. I'd be hard pressed to put something that I think is really mature enough now to do that. Even in the space of generative AI, I think we're still, trying to find our way in terms of the right governance models of these. One of the things that I'm encouraged by is the fact that on these questions, there's actually a really good space for collaboration. And a lot of what I've done, in the last decade is to push towards ways to democratize AI through the work that we've done on open sourcing AI models. And so I do think on these questions, there's a wonderful space to collaborate together and build together. Specifically on the question of benchmarking, there's organizations like ML Commons that have brought together many stakeholders trying to build out new safety benchmarks. Now, those safety benchmarks right now are not necessarily focused sufficiently on agentic behavior, but there's certainly promising ways to do it. I do think from like a more government regulatory point of view, we haven't even seen, I would say, durable regulation for generative AI. And so I think we're going to have to just put our heads together to figure out how to navigate that in the space of agents. Transparency to me is always a good starting point. And back to your earlier points, I do think that running a lot of pilots is necessary for us to know what that looks like. So even from a regulatory point of view, framing up what are the pilots in terms of having an ability to identify the right vectors of risk, to track the impact, the negative impacts that's coming out of a class of agents, that would already be useful information to then inform a stronger strategy.
No, that's great. So earlier this morning, Janet Lin said something really prescient, which is to move fast later on, you need to have good governance guidelines set up first, so that the organization is moving, lockstep. Now, Cari, Canadian Tire, I continue to be impressed with the degree of implementation that you led. What guardrails were really important for you early on to make sure that everything was, governed well?
Yeah, and I think I just want to preface it with, it wasn't specific to agents. It was specific to AI in general and more generative AI. But a few things that were really important were explainability and auditability. And I think now in a world of agents, just like you'd be managing people, you might want to ask that agent, well, why did you make that decision? So you need to really have that auditability. The second thing is really authority and access to systems. And so once again, when you have autonomous agents that are working together, you need to ensure that the access control is specific to the role of that agent, no different than a person. And then I think the other part of it is really around ensuring, and it goes back to the people side of it, is ensuring that the organization has the AI literacy and the understanding of the opportunities that AI can bring, but also the risks that go along with it, and that they're educated on what they should be doing and what they shouldn't. And as a company, you have the right controls in place and the right policies to really govern and manage that.
No, that's great. So with a few minutes left, what I'd like to close on is what's next. So bring out your crystal ball or magic wand if you wish. And if I could ask each member of the panel to think about the next 12 to 18 months, because none of us know what 2 to 3 years out is, and the evolution of agents. What are the big breakthroughs or challenges or shifts that you're looking at? Like, what is that one thing that you're tracking in the next 12 months?
Yeah, so I'll go first. So, I mean, we've seen over the past even 6 months, like vibe coding solutions, come to market. And I've seen firsthand how software development has changed, where before, if anything, the solutions we had before, similar to a Tesla self-driving, now it's more like a Waymo, right? You're not driverless, steering wheel-less Waymo. And it's incredible, it's prolific. The code that it writes is really good. What I'm seeing in market from some of the frontier labs, and maybe you can comment on what's happening at Meta, but I'm seeing that, one, there are arguably super intelligent models, and they're being tuned to essentially think for billions of tokens on a single prompt before responding. Now, that to me is an existential threat, right, to knowledge work in general, and simultaneously an opportunity. So I've seen with software engineering, with vibe coding, that I don't think it's replaced workers, at least in my field of view. I think it's increased productivity expectations. It's increased the quality of outputs and the velocity by a huge margin. And I think with, in all other aspects of knowledge work, with the proliferation of MCP and tool access and the ability to connect these agents to different systems, as the models get better and better, we're just going to have other aspects of our day-to-day lives completely transformed in the same way software engineering has been. Because they're going to get more reliable, the more unstructured tasks that have nuances. They're going to get better at understanding our intentions when we ask them things, with less massaging needed to actually make it work. So that's all I can say is just better, more powerful models that will scare us.
I love it. It's so the era of vibe anything related to knowledge work.
I like that.
Joelle.
A big plus one to Anand's point specifically about coding agents. I do think we're seeing huge progress in that area. The nice thing about coding is in many cases it's verifiable behavior. We haven't talked a lot about that, but within the space of agents, there's some whose behavior you can actually formally verify, and there's some whose behavior it's a lot harder to formally verify. So it's going to be easier to make progress on the first class rather than the second. I'm also personally really curious to see what we can do in terms of the interaction between these agents. We've seen some emerging protocols. MCP is one that you mentioned. If there's going to be a convergence between these protocols that facilitates the development of agents and the sharing of agents and the interaction between them, I think that's going to be really interesting to see. That opens up the door to a lot of really interesting, of course, I'm more focused on the research, and so it opens up the door to a lot of really interesting questions in terms of mechanism design. We talk about governance, but there's even just the question of, what do we put in place to put guardrails around the behavior of systems of agents, not independent agents, that I think is a really important question.
Awesome. So I'm getting the red flag, so you have 20 seconds.
20 seconds. So I see this as our moment as humans to really to drive agency. There's never been a better time to think differently and act differently. And I think it's incumbent upon all of us to take the opportunity and do something different.
Thanks, everybody.
Thank you.